Okay, here is the precise definition of an exponential function. An exponential function has a base, a, or an exponential function with a base a is defined as follows. F of x is a raised to power x. And we necessarily need a to be positive and a not to be 1. Okay, a to be positive because if not, um, we have problems with the negative numbers. Negative numbers can create complex numbers, they can create oscillations, and not equal to 1 because 1 to the power x is 1. This is not exponential. It's just a constant, right? So it's a straight line. So let's look at these two functions. Fx equals 2 to the x. If I make a table of various input values and output values, okay, let me start with, say, 0 and then some positive and some negative. So let's do the positives first. 2 to the power 0, any number to the power 0 is 1. 2 to the power 1, that's 2. 2 to the power 2 is 2 times 2, so that's 4. Then you keep doubling it. What about negative 1? Now 2 to the power negative 1, when you have a negative exponent, it means it's 1 over 2 to the positive version of the same. So this would be 1 half. Similarly, negative 2 would be 1/4, negative 3 would be 1/8, and negative 4 would be 1/16. So what we see is that as my input increases, my output increases. At 0, it is always 1. And as my input decreases, my output decreases. So it goes like that, and it goes like that. Now, what if I change this 2 to 1 half? If I change this 2 to 1 half, we will notice an interesting pattern. G of x, let's say we have 0, 1, 2, 3, 4, negative 1, negative 2, negative 3. To the power 0 will still give me 1, but this is going to be 1 half, 1/4, 1/8, and 1/16. Whereas if I do 1 half to the negative 1 and I flip it, I get back 2. So this would be 2 squared, which is 4 and 8. So these get reversed. Now if the entries get reversed, then what is happening is as x increases, this decreases, and as x decreases, this increases. This point being the same, so they kind of just flip. Okay, which makes sense. If you think about transformations, this is y equals 2 to the x, and this is y equals 2 to the negative x. So going from here to here, you do an x replace negative x transformation, which is what? That's just reflection on the y-axis, which makes sense. Now, some important things to note about the graph and the function, right? So we have y equals a to the x, right? A is called the base. Now, if a is larger than 1, right, then you always have a shape of this form. This point is always 0, 1 because when your exponent is 0, then your result is always 1. If a is less than 1, let me use a different color for that. If a is less than 1, then it becomes this shape. Okay, and why is that? Well, if you take a number less than 1, like, 0.5, when you square it, you get 0.25, and then you get 0.0625. So it's becoming smaller. Yeah. You take a small number and you multiply with itself, it gets smaller. You take a larger number and multiply with itself, it becomes larger. Okay. And that's why, so you have two characteristic graphs, both going through the point 0, 1, right? Because anything to the power 0 is still 1, whether it's less than 1 or it's greater than 1. So if your base is larger than 1, then you're increasing. If your base is less than 1, you are decreasing. Now let's look at some transformations. Firstly, I'm just going to make a list of how to get here, right? So this would be 2 to the x replaced by negative 2 to the x and then add 1. Okay, so this transformation is replacing y by negative y. This is add 1. What do each of these things do? This is reflect on the x-axis, and this is vertical shift up by 1. So my base graph is that because 2 is more than 1, then I reflect it. So once I reflect it, it's going to look like that. So 0, 1 becomes 0, negative 1, and then I shift it up by 1 unit. If I shift this up by 1 unit, it's going to be exactly at origin. So this would be 0, 0. And then you can check. If x is 0, this becomes 1 minus 2 raised to power 0, which is 1 minus 1, which is 0. So it goes through the origin. The next one here, this is simpler, 2x to 2 to the x plus 1. So the transformation we are going on here is replacing x by x plus 1, which is a left shift by 1. So I start with a graph for 2 to the x, which is that, and then I left shift this by 1. Now if I left shift this by 1, this point is going to go to the left. So it's going to be at 1, 1. So I have to figure out what is this new point going to be. Okay. To figure out this point, I need to find what happens when x is 0. So if I have 2x plus 1, when x is 0, this is 2. So this point is now 0, comma 2, which kind of makes sense, right? The point 2 is somewhere here, so when you move it left, now that's going to be the intercept, while this moves more to the left. So the important point that you need to mark, or I guess the two important factors when you're plotting these functions is, first of all, the nature, right? Meaning it's either going up on the right or it's going up on the left, depending on the value of the base. If base is larger than 1, then you increase to the right. If base is less than 1, then you decrease to the right. And the second thing is this intercept. That's where it goes through the y-axis. Okay, so that's it. So that was the definition of exponential function, what the graphs of exponential function look like. And I guess once you have the graph, where you can also talk about domain and range. And these functions, they have domain is everything because you can plug in any exponent, but the range is necessarily 0 to infinity. Okay, because y equals 0 is a horizontal asymptote, it's never going to touch. However, you can get any other positive value. And it cannot be negative because by definition it's not negative. You're not taking, when you multiply a number a bunch of times with itself, that you can't really get a negative, right? Unless you start with a negative, but which we're not starting with the base being negative. One thing, important thing here to understand is that the input is the exponent, right? So it can be negative. In the definition, there was saying that the base has to be positive, but the base is not the input. The base is fixed. That's the number you choose here. That's what cannot be negative. This can be negative. A negative exponent just means it's a fraction. So that works out with the definitions all right. That's it for this video. Next video, we're going to look at some applications and some scenarios where these exponential functions arise naturally. Thank you.